Welcome back everyone, Professor Cameron here. Now in our last video we went ahead and we put this assembly together. So what we're going to do is we're going to go ahead now and create the assembly drawing for this. Now, unlike our part drawings, our assembly drawings aren't really showing the dimensions of our object. We're not showing how to make the object, we're just showing how all the parts fit together. So as far as annotations go, this is actually going to be a lot less cluttered and a lot less notes than we would expect on a part drawing. So what we can do is we can go ahead and go to File and make drawing, sorry, wrong part, File and make drawing from assembly. There we are. So make drawing from assembly, and we're going to go ahead and put this on a B format paper. Like we always do, we're going to set our drafting standard. We're going to go to Document Properties and set our overall drafting standard to ANSI. Perfect. So now we can go ahead and drag on our views onto our drawing. We're going to select from our view palette, and you'll see we have our standard front view, top view, right side view. And we also have ISO and ISO exploded. Now, since we're showing how all the parts fit together, we're not really concerned with showing our front view, top view, right side view. Each of those is going to exist on each of the individual part drawings. So what we're going to do is we're going to select isometric exploded. Just click and drag that on. And that looks pretty good. What we're going to do is go ahead and blow this drawing up. So we're going to set our scale to 1:1. Let's see. Let's go ahead and set that back to 1/2. I think we can set this manually on our left-hand side. Use custom scale. User defined. Let's do 1.5. That looks pretty good. So we have our exploded view on here. What we're going to do is we're also going to put on a view that shows this in its collapsed state, or in its standard state. So under view palette again, we're going to select just a regular isometric view. Now you'll see when I put that in, it locked it to either the top or the bottom. That's not really ideal for us. What we want is to put it over here somewhere on our right-hand side. So what we're going to do is we're going to right-click on this, select alignment, and then break alignment. And then we should be able to click and drag this over here. And this is just going to serve as a reference for us. It's going to show how this part sits together when it's complete. Now, realistically, we could swap these places here. But for us, I think for what we're doing, this makes the most sense here. So once we've got our views on, what we're going to do is go ahead and put in what's called a bill of materials. Now, a bill of material, it exists on every assembly drawing, and what it does is it tells you all of the components that live inside this drawing. For this, we're going to come up here to Tables and Bill of Materials. What we're going to do is we're going to select this view here so it knows which parts to get. And then on our left-hand side, under BOM type, Bill of Material type, we have three options: top level, parts only, and indented. Parts only is going to list all of our parts out in an Excel sheet by the individual components. So each individual component that makes this up, it's going to list it out. Top level only. If we made this assembly using other smaller assemblies, top level only would only list the assemblies that go into this. It would not list all of the individual parts. Indented only sort of combines the two, or indented combines the two. It shows the assembly and then it shows all the parts for that assembly. Typically, if you are making all of your components in-house, you would do parts level only. If you are sourcing ready-made assemblies from someone else, you would do top level only or indented. To put this into perspective, if you were a company that builds transmissions, you would probably do parts level only because you're probably building all of the components in that assembly or in that transmission yourself. If you then sell those transmissions to Ford, and Ford is building their cars and they're doing the drawings, they would do top level only. Because they're not building the transmissions, they don't need to know all the components that go inside. So what we're going to do is we're going to select parts level only and OK. And that's going to give us this chart here. We can place this on top of our title block. This is typically where they sit. And what this is going to include is an item number, a part number, a description, and the quantity. Now, item number, this is just a item number assigned to it in the assembly. This doesn't really have any bearing on our part at all. Part number, this is whatever we call our part number on our drawing or on our part. In practice, this is going to be a randomly generated number assigned to you by your company. Think of it kind of like a social security number for your part. It's a unique identifying number tied to this part and drawing and this part and drawing only. And each of these is going to be different. For now, we just have these as whatever we call them. Description is just a vague description of your part, similar to your title. And quantity is how many there are. So what we have is we have our exploded assembly and we have our title or our bill of materials, but there's really nothing connecting these two. So what we're going to do now is put in what we call balloons. What balloons are, it's going to show the item number for each of the parts on this assembly. Under our annotations tab, we have a tool called balloon. And we're just going to come through here and click on each one of these parts. And you'll see it tied this to balloon 4. Item number 4 is our collar, which is correct. So we can do that for the screws as well. The bearing and the base plate. Now, for the screws, where we have just one type of screw, we really don't have to label each of the screws because when we look at screw 3, it tells us we have a quantity of 2 of them. However, if we're building an assembly that uses multiple different types of screws, then it might become prudent to flag each screw. That way you're not getting them confused in the bill of materials. So what we're going to do, just for the sake of doing it, is we're going to flag both of these screws. And that looks good. So now we can see each item, where it sits in our title block, or in our bill of materials. And that looks good. So this is all complete now. So what we can do is go ahead and fill out our title block like we normally do. To do that, we're going to right click and edit sheet format. And then we can fill this out in the typical fashion. Now, when it comes to tolerances, we don't have dimensions on this drawing, and we don't typically dimension assembly drawings. However, that's not always the case. Like I said, we're not showing the size of the parts, but there may be situations where we need to dimension the location of a part. Say we have to epoxy or we have to weld an object to a large plate. We might want to dimension the location of where it sits on that plate. So we're not setting the size, we're just setting the positioning. As a result, we're going to go ahead and fill this out in the typical fashion as well. Now for material and finish, we could leave these blank. I don't like to leave blank spaces on drawings. So what I put in here is a note called see your bill of material. And for finish, we can put in a non-applicable sign. We're not using this on a next assembly. In this case, this is our assembly. So we can leave this blank. And then we can delete this proprietary and confidentiality box. So this looks fine. This looks good. So what we can do is we can go back to our full sheet. And then this is typically all we would have on an assembly drawing. They're not usually very complex. We may include some notes in here. If we have to use a certain torque setting to screw these screws in, if we have to apply an adhesive or a solder to any of the components, anything like that, we could put in a notes section. So let's just say for the sake of argument, we have to torque these screws to 10 inch-pounds. How would we annotate that? Well, what we're going to do is we're going to create a notes section like we usually do. Now, when we create our notes, we would have just our general notes like we usually do. However, if we're assigning them to a certain part, what we're going to do is we're actually going to put this note in a box. So what we're going to do is note 1 and then torque to 10 inch-pounds, right like that. We're going to put this note somewhere up here. And then because we have this as note 1, we want to put that note 1 on this arrow here. To do that, we're actually going to sketch a box around this note. So it'll look something kind of like this. And we can edit our line thickness. Let's see. There we go. Delete those out of there. Perfect. That's a little thick. We'll trim that down a bit. Come on, now it's fighting with me. Okay, so we've got our 1 in a box. What we're going to do is we're going to come over here to note 3. We're going to put in another note of 1. And we're going to sketch that in a box. Right like that. That way when somebody comes across this part here, they'll see note 1, they'll know that there's an action applied to that, and they'll come over here and figure out that they need to torque it to 10 inch-pounds. And we can do this to both of these 3s. Right like that. So once we have this, our drawing is complete. So what we can do is we can go ahead and save this drawing, and then we can save this drawing as a PDF. And the PDF is what you guys are going to be submitting to Blackboard. So if you guys have any questions on this, please let me know. And as always, have a nice day.